Now let's discuss what is cryptography and hashing. So whenever you are communicating over a network or you are sending an email which have some confidential data, you don't want any third party to steal your data. So this is where the role of cryptography comes. So cryptography is a practice of secure communication in a presence of third party. That third party is known as adversaries. So an adversary is a third party whose aim is to prevent different parties to communicate each other or to steal their data or to change their data. In order to solve such kind of problems, we use cryptography. So a cryptography is of three types. It's symmetric, asymmetric and hashing. Now let's see what is a symmetric key cryptography. A symmetric key cryptography is a type of encryption in which the same key is being used to encrypt the data and to decrypt the data. So what that means? That means if you are trying to send an email over a network and you are encrypting your email with a password, let's say the password is ABC. Now in order to decrypt that email, you need the same password which is ABC. So the same key is being used to encrypt the data and to decrypt the data. The example of symmetric encryption is AES, which is Advanced Encryption Standard, and DES, which is Data Encryption Standard. One of the major drawbacks in the symmetric encryption is both the sender and receiver use the same key. Now this drawback is being solved by the asymmetric encryption. Now let's see what is an asymmetric encryption. An asymmetric encryption is a type of encryption in which the sender encrypt the data with the receiver's public key and then receiver decrypt the data with its own private key. That means you are using a public key to encrypt the data and then the receiver using its own private key to decrypt the data. So that's why this encryption algorithm is also known as a public key encryption algorithm. Now we can see it is more secure when compared to the symmetric cryptography since the sender don't know the private key of the receiver. The example of asymmetric cryptography is the RSA algorithms, digital signatures and the elliptical curve cryptography. Now let's see what is a digital signature. A digital signature is a type of signature in which you can prove that you have the private key of a public key without actually revealing the private key. So if someone asks you if you have the private key of that public key, so you give them the signature to prove it. A digital signature scheme basically consists of three steps. The first step is in which you create your public key and private key. So once you have your public key and private key with you, the second step is you have to sign a message with your private key. Now once you sign your message with the private key, then you share that message with the receiver. Now the receiver validates the message with the verifying algorithm. So we have a signature verification algorithm in place which can validate whether this public key corresponds to your private key or not. Now when the message gets received by the receiver can validate your message by using the signature verification algorithm. So these three steps together make the digital signature scheme. Now let's see what is a public key and private key. Let's try to understand this concept by taking the Bitcoin example. In Bitcoin blockchain, private key and public key is being derived on an elliptical curve and the equation of the elliptical curve is y square is equal to x cube plus 7. So in order to draw this curve, you have to give input to the x and you will get corresponding y. So based upon the x and y, you will get an elliptical curve which will have all your public key and private key associated with it. SEC-P 256K1 standard is being used by the Bitcoins that defines the limit of the public key and private key. So a private key is an input to an algorithm and that algorithm gives the corresponding public key by using a trapdoor function. Since the public key is being generated by a trapdoor function, it is practically impossible to reverse engineer and get the private key from the public key. Now how does this private key looks like? So in Bitcoin, the private key is basically a 256-bit number which is a combination of 256 1 and zeros, which can be represented in different ways. As you can see, it is represented in a hexadecimal form on the screen. Also a public key is a 256-bit number which is combination of 1 and zeros, which can be represented in multiple forms such as hexadecimal forms. Now since we know that a private key is a combination of 256 bit, that means it is a combination of 256 zeros and 1. Is it possible to brute force and find someone's private key? Now let's come to the probability. So the probability that someone will find your private key is same as someone guessing coin toss 256 times in a row, which is practically impossible to do. Now let's do some mathematics. The probability that someone will guess a coin toss right in one time is 1 by 2, and the probability that someone will guess 2 coin toss in a row is 1 by 4. So if you keep on doing that 256 times, the probability that someone will find your private key is way less than someone is actually shuffling the deck and then resulting in the same deck after shuffling the deck. You will find out that probability of finding someone private key by brute forcing, that is by trial and error, is way less than probability of shuffling a card and that card end up in the same order. Now let's discuss what is hashing. And hashing is a way of generating a text from a string by using some mathematical functions. And it is impossible to decipher the output. That means if you have the output, you can never decipher or reverse engineer to get the input. So the main difference between encryption and hashing is, in encryption we have a mechanism to decrypt the data. That means if we encrypt the data with some private key or we are encrypting the data with a password, then we have a mechanism in place by which we can decrypt the data and come back to the input. But when it comes to the hashing, it is a one-way mechanism in which if you have the output, you cannot go back to the input. One more characteristic that the hashing provides us, it's fixed length of output. That means if in case you have the invariable length of input, that means you have no idea what is going to be my input length, but you want an output of a specific length. So you can use hashing. So one of the characteristics that the hashing provides us is a one-way mechanism. That means if you have the output, you cannot reverse engineer it to get the input. So in case if you have invariable length of input, but you want to store a fixed length of output, then hashing is the solution. Also, hashing saves a lot of memory because of a fixed length of output. Now, since the hashing is an irreversible process, there is no way to go from output to input where we can use the hashing. One of the practical application of using hashing is for storing the user passwords. Hashing is also broadly used in different blockchain networks like Bitcoin and Ethereum network. Bitcoin use SHA-256 hashing algorithm and Ethereum use SHA-3 hashing algorithm.